Hello, viewers. In today's session, we are going to discuss a very important and conceptual problem from periodic functions, right? And here we have this interesting problem in which we are given a function g of x that is equal to tangent of square root of greatest integer of n plus 1 x, and if the period of this function g of x is given to be pi by 6, then we have to find the range of this number n, right? So here we have to make use of some important concepts. So the first concept is that the period of uh, that is the tan function, that is tan theta, is given by pi, right? And from the definition of periodic function, we know that if we have a function say f of x, and if this function f of x has the period say t, then f of x plus t is equal to f of x, right? Okay, so now we also know that if we have a function say f of ax plus b, then the period of f of ax plus b is given by t divided by the absolute value of this number a, where a is some real number except 0, right? Provided the period of f of x is given to be t, right? So now we'll make use of this concept, that is, if f of x has period t, then the period of f of ax plus b is given by t over mod of a. So if the period of tan theta is pi, then the period of tan say a theta is given by pi over the absolute value of a, right? So this concept is also used here, which is derived from this one. So let us come to our given function. So here we are given g of x is equal to tangent of the square root of greatest integer of n plus 1, and here we have x, right? So let us take this quantity, that is the square root of the greatest integer of n plus 1, as a, right? So we can take a is equal to square root of the greatest integer of n plus 1, so that this function g of x takes the form that is tan of ax, right? And the period of tan of ax is given by pi over the mod of a, right? So let us denote the period of tan of ax as t, right? So now this period t is given by pi over the mod of a, and here we have pi over the mod of a is square root of n plus 1, and here we have the greatest integer, right? So we have mod of the square root of greatest integer of n plus 1, which can be written as pi over square root of greatest integer of n plus 1, right? And this period t is given to be pi by 6, because in the given problem we are given that the period of g of x is pi by 6, so this t is also given as pi by 6. So here we can now write pi by 6. So we have now this equation, that is pi over 6 is equal to pi over square root of greatest integer of n plus 1. And now we have to solve this equation for n. So now using the cross multiplication here, so we have pi times the square root of greatest integer of n plus 1, and here we have pi times 6, right? Now this pi and this pi get cancelled. We are left with the square root of greatest integer of n plus 1 is equal to 6, right? So now we have this equation. So let us take the square of both sides to get rid of this square root function. So we have greatest integer of n plus 1 is equal to 6 square, right? So the greatest integer of n plus 1 is now equal to 6 square, which is 36, right? So now we have this equation involving the greatest integer function, that is greatest integer of n plus 1 is 36. Now we have to make use of the definition of greatest integer function to get the range of this number n. So now let us take the help of the real number line. Suppose this is our real number line, and here we have say 0, and here we have 34, then we have 35, then we have 36, and here we have say 37, right? Now the greatest integer of n plus 1 is equal to 36, and from the definition of greatest integer function, this quantity n plus 1 has to be between 36 and 37 for the greatest integer of n plus 1 equal to 36, right? So the n plus 1 should be either equal to 36 in order to satisfy this equation, or it should be greater than 36 but less than 37, right? So we have this inequality, that is n plus 1 is greater than or equal to 36 but it is less than 37. So now let us solve this inequality for n. So subtracting 1 throughout, we have 36 minus 1 less than or equal to n plus 1 minus 1. And then here we have 37 minus 1. So 36 minus 1 is 35. And then here we have simply n, and here we have 37 minus 1, 36, right? So the range of n is from 35 to 36, including 35. So we can now write n belongs to the interval that is 35. Here it is closed because 35 is included. And then here we have 36, and here we have the open interval. It implies that 36 is not included. So whenever n belongs to this interval, that is 35 to 36, and all the numbers between these two numbers, including 35 and excluding 36, it satisfies this equation, right? See, for example, if we take n is equal to 35, in this equation, then we have greatest integer of n plus 1. So we have greatest integer of 35 plus 1, which is greatest integer of 36, and the greatest integer of 36 is 36, which is equal to the right hand side, that is 36, right? So n is equal to 35. Similarly, if we take any other number, say n is equal to say 35.5, then the value of greatest integer of n plus 1 when n is 35.5 is given by 35.5 plus 1. So we have greatest integer of 36.5, right? And greatest integer of 36.5 is equal to 36, which is our right hand side, right? So this number also satisfies this equation. So similarly, we can take other numbers also, so that this equation is satisfied. So the range of this number n is given by this interval, that is closed to 35 and up to 36, and here 36 is open. It means 36 is not included.